Welcome to Bloom. In this videos, we will be discussing about micro instructions. What does CPU understand? It understands machine code that is in zeros and ones. But the problem is human can't understand machine code. So how can we give instructions to CPU? Mnemonics is the answer for that. It is a human-readable format used by assembly language programs to give instructions to computer. For example, if we want to say that the value stored at memory address 100,000 has to be transferred to register AX, we can indicate it using load AX 100,000. The mnemonics code will be translated into machine code using an assembler. Whatever the generated machine code will depend on the processor, its instruction set format. So, machine code instructions are specific to the architecture of CPU and do not vary between implementations. For example, if we take a machine code for x86 architecture, which adds the content of two registers and stores the result in a third register, it could be like this. It will translate the opcode into machine code, then the operands like this. This is just an example. Here, this is the example of instruction format for Intel 64IA32 architectures. Here you can see the opcode, which the instruction format allocates 1 to 2 or 3 byte opcode and the rest for operand. Here we can see that addressing form specification is used and sometimes SIB scale index base is used or sometimes a displacement bit is used. This is an example of mnemonics format. Here it consists of two parts, opcode and operand. The opcodes are add, inc, mul, div. When we were discussing mnemonics, we came across the mnemonic load AX, within brackets 100,000. Well, you would be wondering why we have used brackets. Well, there are different addressing modes used in mnemonics. If we use a constant value for operand, it's called immediate addressing mode. But instead of this 5, if we use a register name, it's called register addressing mode. So the operand is stored in a processor register. Instead of a register, if we use a memory location, we put within brackets. So the operand is stored in a specific memory address. And if we use a register within brackets, the operand is stored at the memory address specified by the content of the register. Here, if we go to BX register, within that the memory location address is stored and we have to refer that location to get the real operand. And index addressing mode, we use an index. Here move AX, BX plus 4. We go to BX register, get the memory address, add 4 and we have to refer that value in the memory to get the operand. In the relative addressing mode, operand is a memory address that is relative offset from the current program counter. So jump opcode is usually used. As you are now aware, assembly languages are used to write mnemonics. So it's a low-level programming language. There are so many examples for assembly language. For example, we use x86 for Intel and AMD processors. Usually they are written and edited using text editors, but you can use IEDs that support assembly language too. When we categorize assembly languages, there are two main types, one address assembly language and two address assembly language. We use one address or two address according to the number of register it supports as an operand. For example, in one address assembly language, only one register can be used as operand. But in two address assembly language, you can use two registers as the operand. Here in move AX, BX, there are two registers. But in this, only one register. There can be several variations of assembly language that are specific to different computer architectures and microprocessors. According to that, we have to use the assemblers. This is a picture of CPU. CPU has mainly three components: control unit, registers and ALU. It only understands machine code, that is in zeros and ones. When the CPU gets a machine code, the control unit will execute this machine code by decoding the instruction and generating related control signals to perform operations as specified using micro instructions. This is the hierarchy how machine code is executed. Microprogram is a set of micro instructions, and micro instructions are grouped into different instruction cycles. There can be many instruction cycles. In each instruction cycle, there are different phases: fetch, indirect, execute, interrupt. Usually we see fetch and execute in an instruction cycle. In each phase, several micro operations can be executed. Now you would be wondering, what is micro instructions, what is micro operations, and what are instruction cycles. Let's learn them one by one. Here is an example for micro instruction. Load the contents of a register into ALU input register. It's a micro instruction. Micro operations explains the sequence of executing the micro instruction. For example, fetch the content to the specified register from the register file, place the content of the register into ALU input register. All these are micro operation steps. According to the type of the operation, micro operations can be categorized into three main areas: arithmetic, logic, and shift micro operations. In our next video, we will be discussing how micro operations are executed. Thank you for watching the video. Subscribe my channel to watch more new videos.